Hi, I'm Creighton Cooper. I'm automotive instructor at Tulsa Technology Center at the Lemley campus. And today I'm going to show you a video here on demonstration and explanation of a series circuit and parallel circuit. I'm going to use a fuse switch, two tail light bulbs, and a marker light bulb to explain the differences between those two circuits. This diagram here illustrates a series circuit. And in a series circuit, power can only flow in one path. If I have a light bulb that burns out, the other light bulb will not operate. Power will come into here and stop at this point. Likewise, if I made a break anywhere in the circuit, current will be interrupted, either on the ground side or power side. In this circuit, power voltage has to be shared between the two light bulbs. On this circuit board, I've set up a series circuit just like our diagram. I'm using a fused switch and two tail light bulbs. Power supplied through the fuse, through the switch, into the first light bulb, and then out to the second light bulb. Because they have to share voltage, both light bulbs are not very bright. If I make a break anywhere in the circuit, say I cut this wire, both loads will go out, and it doesn't matter where that connection is lost. The whole circuit will go. You can see the light bulbs are sharing voltage by measuring a voltage drop of each load. Be sure that your meter is set on DC voltage, not AC, and that your leads are in the proper location. Your black lead is in the COM port, and your red lead is in the volt-ohm port. To measure voltage drop, I just put my two leads across the load. My first light bulb is consuming about 5.867 volts. The second light bulb is consuming about 6.0506. If I were to add those up, they should equal the actual source voltage of what's being supplied to the whole circuit. Make sure you have a good connection. My source voltage, the total voltage available, is 12.0904, it looks like. The sum, or the total, of my whole voltage drop should equal my source voltage. They will consume it all. But because they have to share, the loads will not be very bright. They will not operate at their optimum potential. Sharing voltage and only having one path for electricity to flow are the disadvantage to using a series circuit for multiple loads. To overcome the disadvantage of a series circuit in our vehicle lighting system, we use a parallel system. In a parallel system, I have multiple branches. Each branch gets a source voltage. They each get full 12 volts. If I had a light bulb burn out in one branch, power is still able to come over and feed to the other light bulb. Rather, in series, when the light bulb burned out, the whole circuit went out. At least in a parallel, part of the circuit will actually operate. If the light bulb, both light bulbs was good, or I had a break in a wire here, I would still have one load operating. One branch would actually operate. This helps with our vehicle lighting. Not only are they brighter, but also as a fail-safe system, just like with our headlights. If these were headlights, one headlight burned out, if they were in series, they both would go out. Since they are wired in parallel, I would at least have one headlight and maybe get home. On this circuit board, I've set up a parallel circuit. I'm using a fuse switch and two tail light bulbs. Power supplied through the fuse, through the switch, and then is split out into branches. Power is supplied to this branch here, and then it's also split off to this branch here. When I turn the switch on, both lights light up. These are the same bulbs I used in the series circuit, but they're much brighter because they actually each bulb gets source voltage. I can prove this by looking at voltage drop. On the series circuit, each bulb only received about 6 volts. In the parallel, this one's get about 11.7 volts. On the second bulb, it's getting pretty close to source voltage, 11.7. My source voltage is 11.9. Some voltage will be consumed by our wiring because of their resistance, but each bulb gets a full 12 volts in a parallel circuit. To prove that parallel circuits are better, I've wired up 2 light bulbs with different resistance in series. One light bulb is a marker light bulb, one light bulb is a tail light bulb. When I turn the power on, we're going to notice the smaller light bulb illuminates. The larger light bulb does not. This is due to a resistance difference between the two. Looking at voltage drops, the small light bulb is consuming about 11.9 volts. The larger light bulb is only getting about 0.1 volts. Remember, in a series circuit, they have to share. But in series, the rules are that the load with the higher resistance is going to get the most voltage. We measure the resistance to prove that I do have 2 different resistance loads. Now remember that it's not necessarily about size, it is about the resistance. So contrary to what you would believe, the smaller one we would think maybe has less resistance. But in fact it does have more. Setting our meter on resistance, on ohms, I can measure the resistance. My resistance in the small bulb is 5.1 ohms. The resistance in the larger bulb is approximately 0.7 ohms. So much smaller resistance as compared to the larger, or the smaller bulb. Written on paper, we will see that we'll have more voltage consumed by the higher resistance. It's kind of like the big bully on the block. He's going to get the most voltage. It will take more voltage to push the current through the higher resistance than it does the voltage required to push through a lower resistance. It does not matter whether the light bulb is wired, the smaller bulb is before, or if I wire it after. The result will still be the same. The higher resistance will take most of the voltage because in series they have to share. If I wire the small bulb and large bulb in parallel, I can overcome the resistance problem. When wired in parallel, both light bulbs will light up. This is because they do not have to share in a parallel circuit. Each branch or each load will receive source voltage. We look at voltage drop test again. Small light bulb is consuming relatively about the same as it did in series, 11.8 volts. But the larger light bulb, since it also gets source voltage and does not have to share, it also receives 11.8 volts. So it is able to light up. And the parallel circuit is much better because, one, I can make a break. One load will still operate. They will also, both loads will get source voltage, so they will operate at maximum efficiency. This concludes our series and parallel lesson. I'm Creighton Cooper with Automotive Service Technology at Tulsa Technology Center, Lemley campus.